So you guys remember in class this lab that we did, and I want you to just take it out again and just review it for a minute. You'll remember that we all made different triangles, and we colored the 3 angles of our triangles, and then tore them apart, kind of brutal, and put them back together so we could add them together in that angle addition postulate to see what the total would be. And we got a grand total of 180. Now, you did that for your triangle. I did it for mine. We also had classmates and everybody in the class, probably 20, 25 or so triangles that were all torn apart, and every single example gave us this result. So we were using inductive reasoning. You need to remember that. We were looking at a pattern from lots of examples. In this lesson, we're going to use deductive reasoning, and we're going to prove for sure that this has to be the total of our angle sum if we add the 3 angles of a triangle together, no matter what triangle it is. Now, before we go into the proof of that, we do have to talk about a postulate, one that we haven't seen yet, but should make some sense. It's called the parallel line postulate. The parallel line postulate says this. I'm going to write it out. If you're given 2 things, you're given a line and you're given a point that's not on the line. This postulate says something about a parallel line, and it is that if you, well, let's draw this out. So draw out a line, you're given a line, and you're given a point that's not on that line. So let's say you've got line L and point P. The parallel line postulate can answer this question. How many lines would go through point P and at the same time run parallel to line L? Think about that. I'm going to say it again. How many lines can you draw that pass through this point, point P? They go through point P and they run parallel to line L. How many lines are there? Are there any at all? Well, I can draw one. Let me just kind of dash it here. This line, just eyeballing it. Let's say this line here is running parallel to line L, and it passes through point P. Are there any other lines that would come through point P also running parallel to line L? Let me just mark these are parallel with my arrows. The parallel line postulate says there is only one. There is exactly one. Exactly one line parallel. Parallel to line L and through the point P. All right, hopefully that's pretty believable. There definitely is one, but there is only one. That's what this is saying. So we're going to actually use this in our proof. Let's go to our notes here. So we're going to prove this triangle angle sum theorem. We're going to prove that the 3 angles of a triangle add to 180 degrees total. And in order to do that, let's start out with our givens. We're given this triangle ABC with our numbered angles 1, 2, and 3. We're going to prove that angle 1, 2, and 3 add to 180, and we're going to do it with a parallel line postulate. So I'm going to ask you guys, can I find a line, let's have it run through point C, that runs parallel to line AB? Our parallel line postulate says there is one. I want you to draw that line in. We'll just do it as a dotted line. And this is a vocab word you need to know. That line that we just added to our picture, to our given, that's called an auxiliary line. Let's spell that. It's A-U-X-I-L-A-R-Y. An auxiliary line. It's a line that we are adding to the picture, and we can justify it. How do we justify this line? We justify it with the parallel line postulate. So it's a line that's not in the original picture that we are adding to help us with our proof. It's a helping line. Now, when we do that, I want you guys to notice we just made 2 new angles, and we're going to use these 2 angles in our proof. So let's number this angle here 4, and let's number this angle 5, and we'll go ahead with our proof. So we're starting out with our triangle angles angles 1, 2, and 3, and that's our given. And our job is to prove that the angles add to 180. I don't know how many lines this is going to take. I just put 6 on there. It might take more, it might take less, I'm not sure. But what statements can we make with this auxiliary line being parallel? Let's mark that with the arrows, parallel to this line AB. In fact, let's write that as one of our statements. So we have our auxiliary line, let's name it line L. Line L is parallel to line AB. And that's by our parallel lines postulate. Now, can we make some statements about the angles? Now that we have these parallel lines, what can you tell me about angle 1? Is it congruent to any of the other angles in the picture? Angle 1. Well, angle 1, and I'm going to say angle 4. Do you guys see this? Angle 1 and angle 4 would be congruent. Can you tell why? Let's write it down. Angle 1, let's write its measures. Measure is equal to the measure of angle 4. How do I know angle 1 and angle 4 are the same? You see the Z that they make? Let me get rid of my colored pencils. You see the Z here with our parallel lines down the transversal? Those are parallel lines. So those two angles, those are alternate interior angles. That's going to be my reason. Alternate interior angles theorem. Okay, what else can we say? Well, can we do the same thing over on the other set of angles? Angle 2 here. Angle 2. What's angle 2 going to look like? You guys see this Z? So what can we say about angle 2 and angle 5? Can we say they're congruent? Indeed we can. Angle 2 and angle 5 have the same measure. So the measure of angle 2 equals the measure of angle 5. And that's also alternate interior angles. We got another Z out of those. Okay, guys, look at the angles around this vertex C, these three angles, angle 4, angle 3, and angle 5. What's their grand total making? Let's add those together. So that's going to be our next line. The measure of angle 4 plus the measure of angle 3 plus the measure of angle 5. What are they equal? We make that straight line, all three of them, so we're going to say that's a 180 total. And we just did what's known as the angle addition postulate. We're adding the three angles together all adjacent right there. Angle addition postulate. Okay, time for substitutions. Make some magic happen. We said a minute ago that angle 4 had a match. What can we replace with angle 4? If you look back at line 3 here, angle 4 is the same as angle 1. So let's change angle 4 in our equation to angle 1. I'm going to bring down the angle 3. And we said a minute ago we have a match for angle 5. We can even see it up here in the picture. Angle 5 and angle 2 are the same thing. So let's make a trade, and let's put angle 2 in that spot and bring down the 180. And that was, we did replacements. What's that called? How do you replace? You do substitutions. That's our substitution property. And that is what we were supposed to prove, that the three angles, 1, 2, and 3, I've got them in a little different order, but I've got all three of them there equal 180, so that is what we wanted to prove, and we've just proven that that is going to work for all triangles. So let's practice it. We're going to find some unknown angles. Here in number 1, we have a triangle. We're missing one angle of it out of our 180 total. So the quickest way to do this is to, let's add up what we have already. So we've got 43 and 73 degrees. Let's combine those and see we've got 116 degrees so far. We're not quite to the 180 total we need. So let's see what will make up the difference. Let's just subtract the total 116 from 180. Let's see, that's going to be 26. I'm getting 64 degrees for the missing angle. 64 degrees right here. Let's put that in the picture. Okay, in number 2, we don't know any of, well, we know 130 degrees. We don't know all of them together. So on this, I'm going to just go brute force. I'm going to add all three angles together, let 180 equal the total. So start with that 5x. That 5x is one angle. Another angle is the 3x plus 2. I'm going to add that in. And I'm going to add my third angle. All three angles added together makes a 180 total. And let's solve this equation. Combine those like terms. How many x's are there? Looking like 8 x's. And what's our total in these two numbers? The 2 and the 132 makes a 132. The 2 and the 130 makes a 132, equal to 180. Let's subtract out that 132 and take it over to the other side. So bring that in. Yeah, wipe it out. Ninja math. So it's 8x equals, oh gosh, I hate this arithmetic. You guys are better at this than I am. Okay, let's see. It's 8 for 48 degrees. You tell me if I make a mistake in class. And then we'll divide by the 8x. Divide by the 8, excuse me. Divide by 8. Leave that x alone. Keep it over there. So x is alone, and 48 divided by x by 8 is 6. All right, so that gives me the value of x. Not done. I have to figure out the three angles. So let's go back up to our picture with x is equal to 6. What's that going to make this angle? We've got a 5 times 6 substitution. That's going to be a 30-degree angle. 5 times 6 there. And then on this one, we're going to take 3 times the 6, add the 2 into that. That's going to be 18, 19, 20. 20 degrees here. Okay, and always check these. Do you have 180 total? If you take 30 plus 20 plus 130, add that up. You should get 180, and you do. A couple of examples here. These are going to usually involve finding more than one angle, not just the one they're asking for, like this one, but a lot of times you have to find other angles they didn't ask you for just to get to the one they want. So in this one, I see a couple of triangles. I'm going to just number them so we can talk about them a little easier. I've got triangle number 1 and triangle number 2 over here. In triangle number 1, I have a 74-degree angle, but I don't know what this part is, and I don't know this one. So I really don't have enough information to figure out what my missing angle is. You'll see in triangle number 2, I know 2 of the 3 angles, so that will get me a start. So I'm going to use triangle number 2. And what do we have so far? Let's add up 76 and 49. Combine those together, and that gives me 125, it looks like. So if I take the 180 total that I need, let me subtract out the 125 that I have. What do I have left over? Looks like 55 degrees. So 55 degrees is the last angle of triangle number 2, and that can go in our picture right here. That's a 55-degree angle. Does that help me? I think it does. If you guys notice, what's that little square right there mean? There's a 90-degree angle there. So if we know one piece of it is 55, can you find the other piece? Can you figure out this part? Because if you can, you got into triangle number 1, and that's going to help you get to the angle you need. So let's take our 90 total, our 90 degrees total, and let's subtract that 55-degree piece. So what do we have left over? If we subtract that, we get 35 degrees. So that means 35 degrees is the other piece of the 90-degree total angle. Okay, that unlocks angle or triangle number 1 for us, because now I do know one of the angles plus the 74 that I had. So now we're in triangle number 2 or number 1. And in triangle number 1, I know 2 of the angles. I've got the 74-degree angle, and I'm going to add that to this 35-degree angle that we found and see what I've got so far. So that gives me a total of 109 degrees so far out of 180. So we've got a last step now. We've got to figure out 180 minus the 109 that we know. And that gives us an answer of 71 degrees, which is our final angle right here to complete the 3 angles of triangle number 1. So 71 degrees is that final answer. You see how we had to work around to it? That happens a lot. They'll ask you for an angle or a measurement, but you have to find other measurements along the way. So just be sure you're showing your work on how you get that. Okay, let's go to number 4. Outside here, we've got this angle that we've got to figure out. Here's my approach to it. Do you see a triangle in there? There's only one triangle in this picture, right here. And I need to know angles of that triangle that are going to help me to figure out this angle on the outside right here. So you might notice right here on that 70 degrees, do we have another angle in there that is 70 degrees? Do you remember your vertical angles theorem? Those 2 lines across, so this is a 70-degree angle also. And 70 degrees there plus 50 degrees there would let you figure out this third angle of the triangle. Let's add that up. So we have 50 degrees plus 70 degrees inside the triangle. We've got 120 degrees so far in the triangle. So if we take 180 of the total and take out the 120 that we just figured we have, what do we have left over is 60 degrees. So that means this angle is a 60-degree angle. I'm going to put it in there. Got a 60-degree angle. Now, that being said, you should be able to figure out what this outside angle is. What kind of angles do we call those two? The 60 and the one right next to it on that straight line, the question. Remember, a linear pair, that's a linear pair that keeps showing up. So, if that's a linear pair, then this should be 180 total. 180, and I'm going to subtract out the 60 degrees that's here. And that gives me 120 degrees for this other piece. So that's my final answer on that one.